Part 3 of Lesson 4, Chapter 2 is going to be on factoring and finding the zeros of a polynomial function. If you look at this example, you're given a fifth degree polynomial, which means by the fundamental theorem of algebra that it has 5 zeros. They might all be real zeros, or it might have a combination of real zeros and imaginary zeros. But it's going to have 3 parts to these problems. It's going to say part A, write the function as a product of linear and irreducible quadratic factors. And then part B, write the function as a product of linear factors. And then part C, list the zeros. Now to do these problems, you're going to have to know some zeros that already exist. So this is a fifth degree polynomial. You look over here to the side, I'm giving you 3 of the zeros. So we can come right over here to part C and we can write down 3 of the zeros. And there's going to be 2 more that we got to come up with. Okay? So keep that in mind. There's going to be 2 more that we have to come up with. Now, to find the other 2 zeros that we're missing, we're going to use synthetic division with each of these zeros, and that's going to help us find the remaining 2 zeros. So it doesn't matter which number we start with. I'm just going to start with 3. I'm going to do synthetic division. Now notice we're missing an x to the 4th term, so I have to put a 0 there. And because we know that 3 is a 0, I should get a 0 at the end of this. If I don't, I made a mistake someplace. Sure enough, we get a 0 at the end, so everything's working out. Now I move on to another 0. I'm going to take the next one, 2, and I'm going to build off these resulting coefficients. And again, I should get a 0 at the end of this. Sure enough, we get a 0 at the end. And then we do this one last time with the third 0 that was given to us, -5, and again, we should get a 0 at the end. This confirms that we've done it correctly. And now I take these resulting coefficients, and that's going to help me write part A, product of linear and irreducible quadratic factors. So I'm going to say k of x equals x plus 5 because -5 is a 0. I'm going to write x minus 2 because 2 is a 0. I'm going to write x minus 3 because 3 is a 0. And I'm going to take these resulting coefficients down here at the bottom, down there, and I'm going to write 1x squared. I could write plus 0x, but I'm not going to write 0x, plus 1. So there's the product of linear and irreducible quadratic factors. Now part B says write the function as a product of linear factors. So to do that, it's going to look almost exactly the same. Oops, excuse me. Let's see here. We're going to have to still have the x plus 5. We're still going to have the x minus 2, the x minus 3. But what's going to be different is that I'm going to have to take this x squared plus 1 and factor that out. So if I take x squared plus 1 and set it equal to 0, and if I solve it, I get x equals plus or minus the square root of -1, which is I, right? So here I'm going to write x minus I and x plus I. So what we're discovering here from part B is that the 2 remaining zeros that we didn't know are positive I and negative I, 2 imaginary zeros. And remember, we have the complex conjugate theorem, which says that if you've got one imaginary 0, then its conjugate also has to be a 0, and that's matching up right there. Example 7, we'll just do another example of the same kind of problem. Again, they give us a polynomial. This one happens to be a 4th degree polynomial, which means that there's 4 zeros. They might all be real. They might be a combination of real and imaginary. And it says part A, write it as a product of linear and irreducible quadratic factors. Part B, write it as just linear factors. And part C, list all the zeros. You can see that there are 2 of them listed already, 5 and -6. We're missing 2 more. So we're going to need to find those last 2. So to do that, we're going to use synthetic division. Again, it doesn't matter the order. I'm going to start off with 5 and write out my coefficients. We got a 1, 1, negative 26, 4, and 120. Should get a 0 at the end because we know that 5 is a 0. What did I do wrong? 34, 20, 24. Oh, I just, up here, I forgot to put a negative sign in front of my negative 120. Okay, so now it's making sense. I'm going to get a 0 at the end. Everything's looking good. And I got to build off of that, use the other 0 of negative 6 with these resulting coefficients. And again, I should get a 0 at the end. Sure enough, I get a 0 at the end. This confirms what we thought would happen. And so now we can write it as f of x equals x minus 5, because there's a 0 at 5, x plus 6, because there's a 0 at negative 6, and then I'll have to write x squared plus 4. And I get that x squared plus 4 from these resulting coefficients. And so then to write it as a product of linear factors, we still got the x minus 5, we still got the x plus 6. This is going to give us x minus 2i and x plus 2i. If you're wondering how I got that plus or minus 2i, which are the remaining two zeros, what I did is I just took x squared plus 4, set it equal to 0, and solve from there. And that's how I got the square root, plus or minus the square root of negative 4, which is equal to plus or minus 2i. Okay? Now, to do the homework problems, you're going to need this information right here. So pause the video and write down these. These are the zeros that you're going to use to find the remaining ones, the ones that are missing. Okay? So you're going to need to write those down to use those on your homework. Have a great night. We'll see you tomorrow in class.